Hello everyone, my name is Aditya Samant. I am a database specialist solutions architect here at AWS. Today, we're going to continue our conversation on Amazon Aurora and its integration with our machine learning services. In the previous video, we talked about Amazon Aurora's integration with Comprehend. Today, we're going to continue on that thread and we are going to talk about Amazon Aurora's integration with Amazon SageMaker. Okay, so let's get started. As part of today's agenda, we will talk about Aurora machine learning and do a quick overview of Amazon SageMaker. We will talk about some of the development challenges and how we can solve with the Amazon Aurora integration with the machine learning services. And towards the end, we'll do a quick demo using this integration and with the churn analysis. Let's spend a couple of minutes talking about Amazon Aurora. Amazon Aurora is a database built for the cloud. It is delivered as a managed service, and it comes with two compatible engines, either MySQL or PostgreSQL. It brings you the simplicity and cost effectiveness of the open source world, which means there is no licensing cost, and it gives you the throughput and availability of the commercial database engines. All of this comes with the promise of AWS of simple and pay-as-you-go pricing. Let's take a look at AWS machine learning stack. AWS machine learning stack is pretty broad and deep. It has 3 layers of services. The top layer is our AI services, services like Amazon Recognition, or Poly, or Comprehend. These services are usually an API endpoint. You don't have to learn machine learning, or you don't have to train the data. You simply just consume this service as an API endpoint. The second layer is Amazon SageMaker and its companion applications like the Studio IDE, Neo, Marketplace, and more. And towards the end, we have our machine learning frameworks and infrastructure that is bundled with our EC2 and our container services. Today, we're going to talk about the second layer, which is Amazon SageMaker. Let's take a look at some of the issues that we face when we try to build a machine learning application where we're trying to take advantage of our relational database data and we're trying to enrich it and derive insights from it. Usually it's a 6-step process. Step number 1 is to select and train the machine learning model. Step number 2 is to write an application code to read the data from the database. Step number 3 is to format the data to fit the machine learning model. Step number 4 is to now call the machine learning service and then use this data and run through that machine learning model. Step number 5 is to again format that data so that the application can actually consume it. And then final step is to load the results to the application. Because this integration is so complicated, what usually ends up happening is a data scientist or a developer usually takes a data source like a relational database, downloads that in a CSV format or some other format, then puts it on their database or puts it on their laptop or workstation, and then runs it offline through the machine learning model. Then takes that enriched data and the predictions and then loads it back into the application. So the challenge we're trying to solve, or the goal here, is to take this offline model and bring it online. So how do we solve this challenge with Amazon Aurora? Amazon Aurora machine learning integration is simple, optimized, and secure, and it connects Amazon Aurora with 2 of our machine learning stack services, which is Amazon SageMaker and Amazon Comprehend. This integration lets you do machine learning predictions on relational data. It helps you enrich it. It helps you derive insights from it. And you can do it using your familiar SQL languages, so you don't have to learn new languages like Python or R. This is done in a very low latency, almost immediate way. So the latency or the amount of time it takes for you to get the results back from your machine learning stack is going to be very low, usually in milliseconds. This integration is part of your familiar AWS secure environment, so you can take advantage of your governance and compliance rules that you utilize for your regular operation with AWS. So this Amazon integration between Aurora and machine learning takes the 6-step approach that we talked about before to 3 steps. where now you just select a machine learning model using SageMaker. You run a SQL query to invoke a machine learning service, and then you just use the results in the application. It becomes really, really simple. So here are a couple of examples. The first example is to find suspected fraudulent transactions. So if you imagine that you have a banking application, and in a banking application, you're inserting a transaction into a table. What you can do is you can create a trigger, and this trigger basically sends the data that's being inserted back to the machine learning service. Let's say you have a model that can actually look at this data and make a prediction whether this is a fraudulent transaction or not. And if it is a fraudulent transaction based on machine learning prediction, then you don't insert it into the table, or you just keep it aside for processing later. Another example is prioritizing customers based on their predicted future spend. Again, here's also another banking example where you have an application and you can figure out if, based on current spending of a customer, if they are going to be a good fit for a certain type of promotion or not. Again, you basically take that data that is in your relational database, you send it to the machine learning model, and you get the prediction, and then you can prioritize these customers based on the prediction. So that brings us to demos. So today's demo, we are going to basically see a customer churn example, and we're going to use Amazon SageMaker in the backend for that. Before we actually get to the demo, I wanted to quickly show you the steps of the demo. So the first step is to deploy the model, which is part of the pre-work, right? So in the real world scenario, either you have a data scientist or you already have purchased a machine learning model that's ready to go. So we will quickly look at this model before we actually start doing the integration. Step number 2 is to establish trust between the Amazon Aurora and SageMaker using IAM role. Step number 3 is going to be about modification of some of the parameters on Amazon Aurora. And here's the important step. The SQL function that we're going to use is going to use a clause called AWS SageMaker invoke endpoint. We'll look at it in detail when we do the demo. Here's quickly how the function looks like. If you look at the function, most of the function looks like exact SQL function. There are no changes. It's just a regular SQL function. The only change is towards the end where we are calling an alias, and then we're saying AWS SageMaker invoke endpoint, and then we're providing the name of the endpoint. And we'll look at all of these steps in details in a minute. Okay, to start our demo, we're going to head over to our AWS console, and there we're going to go to the Amazon SageMaker console. In Amazon SageMaker console, on the left-hand side, you're going to see a notebook area. The notebook area lets you define Jupyter notebooks. So let's go ahead and take a look at these notebooks. The notebook I'm interested in is the Aurora Machine Learning Demo Notebook. So let's go ahead and open it. So it brings you to this area where you can open up the Amazon or the Jupyter Notebook. And here's my Jupyter Notebook. So let me open that up. So this Jupyter Notebook defines a bunch of Python code. So some of this Python code imports libraries, it defines an S3 bucket, it imports the data that we need to train the algorithm, it classifies that data, it imports the framework that we're going to use. The framework's name is scikit-learn framework. So it imports that framework and then also defines the algorithm that it's going to use, which is the random cut forest algorithm in this case, and does a lot of processing. But essentially what it does towards the end is, after training this algorithm with that data set, it deploys a model in an S3 bucket, and it also deploys an endpoint. So after the processing is done in this notebook, we should have an endpoint ready for us. So to save some time, I've already executed this notebook. So let's head over to our Amazon SageMaker area. And let's go down to the endpoints area. In the endpoint area, here's my endpoint that I need to use in Aurora. So I'm going to click on the endpoint. This endpoint shows me a couple of things. On the right-hand side, you see this URL. This is how you would usually interact with this endpoint. You would use your REST APIs or applications, and they will talk to this endpoint or this URL to get predictions. For us, because we're using Aurora integration, we need to basically run SQL queries. So for that, what we're going to need is we're going to need this ARN. So I'm going to copy this ARN, and I'm going to show you in a second where we use this ARN. And ARN stands for Amazon Resource Name. It basically tells you a unique ID for the resource within the AWS area. So let's go to our RDS console, and I'm going to go to my database instances. I've already spun up a database instance that I'm going to use for this demo. I'm going to go to connectivity and security area, and then scroll down to the manage IAM roles area. Click on the select a service to connect to this cluster. And as you can imagine, the service that I want to connect here is going to be Amazon SageMaker. So I'm going to click on Amazon SageMaker, and then I'm going to click on connect service. So as soon as I click on connect service, it asks me for the ARN for Amazon SageMaker endpoint. So this is the endpoint that we just copied in my last step. So I'm going to paste that here, and then I'm going to click on connect service. It's going to take a few seconds, and then it's going to become active. Okay, so now the role is active. Let's see what this role is doing for us. I'm going to copy the name of this role, and then I'm going to head over to my IAM area. I'm going to go over to the roles area and then look for this role that was just created by the Aurora service. So let's click on this role and see what it's doing inside. So if you look at the policy that was defined by this role, it's basically doing just a couple of things. It's saying allow this action, which is invoke endpoint in the SageMaker service. And it's also defining which endpoint can be utilized, which is identified by this ARN. So fairly straightforward what we're doing here. We're saying let RDS service, or Aurora in this case, invoke the SageMaker endpoint, and we're also telling which endpoint can be invoked. So that's fairly straightforward. The other thing that I wanted to show you is the trust relationship. So we have defined a policy that tells you exactly which resource can be accessed. And also we're defining a trust policy. So we're saying let the RDS service talk to the SageMaker service. That's all. So let's go back to our RDS console. So we took care of the two steps, which is to define the SageMaker endpoints, then take that SageMaker endpoint and create a role. Now what we need to do is we also need to provide a parameter or modify a parameter so that the Aurora service can actually utilize this newly defined role. So let's go back to the configuration area in RDS console. And in configuration area, what we need is the database cluster parameter. So if you see right here, we have our database cluster parameter group listed, which is Aurora MySQL 57 cluster ML. I'm just going to click on it and open it in a new tab. And then the parameter that we need to change is called AWS default SageMaker role. So I'm going to edit this parameter, click on edit. Again, if you see here, it says the default IAM role ARN used for integration with SageMaker. So we are going to get this value from the role we just defined. And this value is right here. So I'm going to copy this, come back here, and then paste this value. Then I'm going to click on Save Changes. Now, if you see under Apply Type, this change is dynamic. So we don't need a reboot to apply this change. Let's make sure that the changes are correct. So it is RDS SageMaker role. and it ends with this number, which is the same as this number, so we're good here. So I'm going to click on changes. And at this point, all the pre-work that we need to do in console is done. So the endpoint is defined, the role is created, and the parameters change, so Aurora knows which role to utilize for the next step. Okay, now we're in MySQL Workbench. Let's take a look at our Aurora version first. It's 2.08.1. As long as we are about 2.07.0, Aurora integration with machine learning is supported. So in this case, we're good. So I'm going to show you the table and the contents of this table that I'm going to use for this demo. And I'm going to talk or spend a couple of minutes talking about the use case and how this machine learning algorithm is trained, so the rest of the demo kind of makes sense. So let's take an example of a row here, and let's talk through this data that was used to train the machine learning algorithm. So this data was made available publicly by a telecom company. This is anonymized customer data, and it has observations. So if you look at this first row that's highlighted, the observation is that this customer was in Kansas State. Their account length was 128 days. Their area code was 415. They didn't have an international plan. They didn't have a voice, or they did have a voicemail plan. And it also goes ahead and does some observations like how much time they spent during daytime on a call, how much time did they spend during nighttime on a call, if they had international plan or not, how much time did they spend on making international calls, if they made customer service calls or not. And along these observations, there's another observation which is noted in the column churn, which basically says either true or false. So if this churn column says false, that means this customer did not leave the service. If it says true, that means based on this information, they found out that this customer actually left the service and went to some other telecom company. So again, this churn column here is part of this table, and all it does is it notes the observation and it tells us whether a customer left the service or not based on all these other pieces of information that was collected. So this is important to understand because we use this data to train the SageMaker algorithm that we looked at before, and that's how the endpoint is defined, which is using this data, and then we are going to use the same data to make predictions also. So since this is just a demonstration, we're using the same data set for training and prediction. In real world scenarios, you would probably not do this. You will use a separate data set for training and separate data set for prediction. So before we actually move on to make any predictions, I wanted to show you the function definition. So I'm going to go over to the function here and then make a copy of that function, and then we're going to observe the function definition. So if you look at the function body, it's fairly straightforward. It's just standard SQL. We're creating a function called churn, and we're saying this function expects these parameters with these data types. Here's the important part though. The clause we're using is the alias clause, and then we're calling AWS SageMaker invoke endpoint. So what we're saying here is this function is essentially accepting all of these parameters, and it's just a wrapper for invoking this endpoint. So this endpoint is the same endpoint that we looked at before in the SageMaker console, and this function is using the SageMaker integration to call that endpoint in the backend. So that's all this function is doing. It's essentially just a wrapper. So now that we understand what this function is doing, let's send a row to this function and see what we get back. So the output column will be named will churn ? So it's just telling us whether the prediction is going to say, will this customer churn or will this customer not churn based on this information we're sending to it. So let's look at this output. So based on this just one row of information we sent, the the prediction is true. So based on this information, state is Indiana, the account length is 65, and rest of the things, the prediction is that this customer will churn. So if you can see, this becomes so much easier to make predictions from right here within your MySQL queries. So let's take this example forward. And what I'm going to do now is, instead of just sending a single row, I'm going to send the entire table. So again, this is a standard function call. What I'm doing here is I'm using the churn function, and I'm passing all the columns from the customers table that I've defined here. And then the output is defined as, or the name of the column is going to be churn ? So let's look at this output. Okay, you see it was pretty quick, less than a second maybe. We'll look at the performance in a second. But if you see the output, if you remember from the previous table description that I was showing, this churn column here is essentially the actual observation, okay? And this churn ? is the output of the function. So if you see, these two columns line up pretty well, which means that we're almost very well our predictions are spot on based on the actual observations and what the SageMaker function or SageMaker endpoint is returning in terms of predictions. So that makes it really easy for calling the SageMaker functions in the backend just using a query. So now that you kind of see how easy it is, let's take this example further and let's look at the performance aspect of this demonstration. So to do the performance demonstration, what I'm going to use is I'm going to use the explain clause. And the explain command basically just shows me the query plan. So if I look at the explain for the single row that was passed before, it doesn't have any extra information. It just says, I sent a query, I got the results back, done. But if I look at the explain information for when I send the entire table, this is the other function call, I have some additional information under the extra column. And this additional information says batched machine learning. So this is an optimization that we have applied or we have created for the SageMaker integration. What we are doing here is we're trying to batch as many rows as possible before we send it to the SageMaker endpoint. So the idea behind this is because if we send individual rows or rows in smaller groups, it takes a lot of times for them to kind of travel over the wire, get the prediction, come back, and that can keep adding, and it can cause performance issues when you're doing predictions using this integration. So our recommendation and kind of overarching advice here is to try to group as many rows as possible and send to your SageMaker algorithm as possible. And that depends on different variables. So one of the things is how many rows can your SageMaker algorithm or the endpoint that you're defined, how many rows can it support? What is the size of the information that you're sending? So there are several things that to be taken into account here. But our advice is send as many or group as many as possible so that your performance is good. So to demonstrate this point, what I've done is I've created a separate function definition. And I'm going to show you the function definition for this second function. So the name of this function is churn max batch 100. So as you can imagine, what I've done is I've used this max batch size clause, and I've changed the max batch size to 100. By default, our max batch size for the SageMaker integration is 10,000. So I have reduced it significantly from 10,000 to 100. So what I'm saying here is instead of sending or grouping 10,000 rows together, only group 100. So in this 3,000 rows, we're probably going to make batches of about at least 30 to send all of this information to the SageMaker backend. Okay, so no other difference really here. The function body is identical except this max batch size. So let's see what happens when we execute the new function definition with smaller batch size. So I'm just going to go ahead and execute this. So it took some time, it came back. It was probably also sub-second. So let's look at the performance schema output and compare these two runtimes and see the what kind of observations we have here. So let's look at the function without batching and then the function call with batching. So here are the two that I've highlighted. So here's the function call with the smaller batch of 100, and here's the default function call where we're batching 10,000 rows. So if you see the difference between these two function runtimes, the duration is dramatically different. When we batch everything together, or 10,000 rows together, by default, we took about 300 milliseconds to run. When we changed our batch size to much smaller batch, which is 100, our duration for executing the exact same query was 1 second. So, it's just running, it's just taking a lot more time, 3 to 4 times than compared to the batched version or the default batching. So again, I'm just trying to reiterate this, trying to drive this point home that try to batch as many rows as possible to get the best performance out of the SageMaker integration. And I'm just going to run this quick subquery to kind of demonstrate the accuracy of the model that we created here. So I am correlating the predicted churns with the actual churns. So the SageMaker endpoint predicted that based on the information that was sent to it, 400 customers will churn. The actual observation was 394, and 6 did not churn. So our accuracy in this case is extremely high. So the SageMaker predictions are almost 98.50% correct. Okay, so that concludes our demo. I'd like to take a minute and summarize what we learned here today. You can use Amazon Aurora machine learning integration to enrich your relational data and derive insights from it. You don't have to be a machine learning expert or a data scientist to do that. You don't have to learn any new languages. You can continue to use the familiar SQL language, and you can derive these insights in an online, secure, and fast environment. With that, I'd like to thank you. I hope you enjoyed this session. I hope you enjoyed the demos. And I'd like to wish you happy cloud computing from everyone here at AWS.